So we need to graph two inequalities. We're going to select 2 points that are solutions to the system, 2 points that are not solutions to the system, and we are going to prove that our 2 points that are solutions work in both of those original inequalities. All right, so looking at these, first inequality, this guy right here, is this in a form where I can just graph it? Yes. What is our y-intercept here? -5. So my y-intercept, 0, -5. So on my y-axis, down here, plot my point. What is our slope? 2 over 1. So up 2, right 1. Up 2, right 1, till we run out of room and can't do it anymore. Make sure we go backwards as well so that we're getting our graph as precise as possible. Is this guy going to be dashed or solid? Dashed. Remember, if we don't have that little line underneath him, it's like this guy with the open nose and the dashed line. If it does have that little line underneath it, it gets a solid line. So we are dashed here. Go ahead and draw my dashed line through these points. And then we need to figure out shading. Are we shading above or below this line? Above. It is a greater than, so it is shade above. I'm going to grab my little highlighter here. And we're shading this side. All right. And then we come down to this other inequality. Thank you. Is this bottom inequality in a form where I can just graph it right now as is, like the one up above? No. What do I need to do to this first then? We're going to add 6x to both sides. The first thing I want to do is get x to the opposite side. So I'm going to bring that over here. So I'm going to have 2y is less than or equal to 6x plus 8. What do I still need to do to this now? Divide everybody by 2. So I end up with y is, do I have to flip my inequality around? Why not? We divided by a positive 2. Down on the bottom of our fraction, we have a positive number. Inequality stays the same direction. 3x plus 4. This is what I'm going to graph now. What's our y-intercept? 4. So on the y-axis, 0, 4. Right here. What is our slope? 3 over 1. So I'm going to go up 3 and right 1, up 3 and right 1. Run out of room that direction, so I got to back it up and go the other way. Down 3 and left 1, down 3 and left 1, until I can't go any further. Will this one be dashed or solid?
Solid.
This one will be solid. So I'm going to grab my straight edge, draw a solid line through that. Question, would these two lines ever intersect each other? I heard both answers. What do we think? Would they ever intersect each other? Yes, sir. Yes, they have different slopes, so they will intersect at some point. I don't see it on this graph, but as I look down towards the bottom, do you see how they're closer together down here than they were up above? They're going to touch each other somewhere below this. So if I was using graphing software, if I was doing this on the computer, I could zoom out like you do on Google Maps, and I would see that they would eventually touch each other here. Do I shade above or below this one? Below. Where do we look for the above or below shading? You look at your inequality right here. It has to be when you've got y all by itself. I never go back to the original if I'm going to use this shortcut. If you don't want to use the shortcut, you have to pick out a test point and sub it in. If it is a less than when it's in slope-intercept form, then we shade below. If it is a greater than, then we shade above. So we are shading below this line, so this space over here. So where is my feasible region? Where is the solution space? 0, 0 is in it, but it's not the only thing. Where would I find points that we can call solutions? Anything that is in between these two lines would be solutions. So let's name some solutions. I heard 0, 0. They asked us to name two solutions. So 0, 0, and what's another one that would work? 1, 1. Absolutely. Anything else? What else could work as a solution? 2, 1 could work. What about 4, 10? Would that work? Yeah. 4, 10, yep, that is in our double shaded space, so that would work. Any of the points in this double shaded space would work as solutions. So this guy up here, this one, this one, this one, any of these points, we could name any of those. Those would all be solutions. I'm going to use 410 as the other one that we're going to test here. Give me some things that would be non-solutions. All right, hold on. I heard -3, 5 first. That one's shaded only red. It's not shaded both. So that is a non-solution, -3, 5. And Precious, can you repeat yours again? I'm sorry, I lost it as I was talking. 10, 5. That would be a non-solution. That one is shaded only blue, but not red. Does it have to have a y part of 5 to be a non-solution? Can you guys give me another example of a non-solution? -3, -2 would be a non-solution. Where else would be a non-solution? 4, -9. That one's shaded only blue, but not both. These are all non-solutions. So I'm going to write those down. -3, -2. -9. Any of those would be valid answers for non-solutions. The solutions it said we needed to test. Said we are going to prove that these are solutions by substituting back into the original inequalities. So we're going to do that. Let's test 0, 0 first. So my first inequality was y is greater than 2x minus 5. I'm going to put 0 in for the x and in for the y. What's 2 times 0?
0.
0. What's 0 minus 5? What is 0 minus 5? You have no money.
-5.
Yeah. -5. You spend $5. You had to borrow it from somebody. Now you're in debt. Which one of these is further to the right on the number line?
0.
0. Alligator always eats the bigger thing. Further to the right is bigger. 0 is further to the right. It is bigger than negative 5. So this is true. All right. We have to test it in the other inequality to make sure that it works for the system. My other inequality was negative 6x plus 2y is less than or equal to 8. What are we putting in for x and for y? Which point are we testing again? 0, 0. So what am I putting in for x and for y? 0. 0 in for x, 0 in for y. Recopy everything else. What's negative 6 times 0? 0. What's 2 times 0? 0. Less than or equal to 8. What's 0 plus 0? Is 0 less than 8? Yes. So 0, 0 works. We saw this on the graph, and we proved it algebraically. Let's test 410. There seemed to be some skepticism about us choosing that point because it was right on the edge of our graph. Let's substitute it in and see if it works. My first inequality is y is greater than 2x minus 5. Be careful before you speak. What are we putting in the place of the y right here? 10. I want the y part of the ordered pair. 10 is greater than 2 times, what are we putting in for x? 4 minus 5. What's 2 times 4? 8. So I have 8 minus 5. What's 8 minus 5? 10 is greater than 3. Is that true? Yes. 10 is bigger than 3. All right, we're going to check our other inequality now. Negative 6x plus 2y is less than or equal to 8. What are we putting in for x again? 4 goes in for x. What are we putting in for y? 10. What's negative 6 times 4? Negative 24. What's 2 times 10? 20. What is negative 24 plus 20? Negative 4. Is negative 4 smaller than 8? Yes. It made my inequality true, and so this is valid. It worked for both inequalities in that system. Do you guys have any questions for me about the bell work? Did you guys have any issues accessing the video yesterday?
At first it was cool, but when I got home it stopped playing right.
Stopped playing correctly? Okay, hopefully it'll work better for you if you do it again. It might have just been like getting on different Wi-Fis. Sometimes that'll affect it. It is available, like if you have an easier time using a YouTube app, you can go to my YouTube channel and it'll be there. You can search for it. I do have a YouTube channel. It is a school YouTube channel, but it's my YouTube channel. If you did not watch the video, this is going to be a little bit confusing because the video walked through the steps for how to solve a system with 3 variables. An equation that has 3 variables is describing a plane, not an airplane. Do you guys know what a plane is? Close. Very close. A plane is a flat surface that extends in all directions. So kind of looking at it like a piece of paper, but it'd be like an infinitely large piece of paper that doesn't have edges. Planes can be oriented any which way. They could be up and down. They can be like this. They could be like this. They can be tilted. They can be all different directions. So we need 3 variables to describe this because while we have this flat surface, it's existing in 3-dimensional space. So if it's like this, I need 3 different variables to explain to me how this is oriented. What we're doing when we solve a system with 3 equations that each have 3 variables, we're finding out where 3 different planes are touching each other? Where are they intersecting at? Actual applications of this is the why you should care part. I did not understand for the longest time why we did this in algebra. Why do we care about this at all? My brother graduated from Ball State, had a degree in art. He didn't think he needed any math classes. He decided to go on and he wanted to do art creation for video games. So he did characters and backgrounds for different video games that came out. Wish I could remember the names of some of the ones that he's worked on. I'll have to ask him and get a list. Do you guys know how they figure out where these different characters are in the game, how they move throughout the game? Have you guys ever seen video games glitch before?
Yeah.
Systems of three equations. This is three-dimensional space. Your characters can move forward, backward, towards the screen, away from the screen. I'm not talking like side-scrolling Mario here. Systems of three equations with three unknowns is how they figure out where in space these different features are. So as you walk towards an object, how do you know when you actually get there, when you touch it? My brother had to teach himself this on his own when he was done with school so that he could do his job. So we're going to get into kind of the background of where that's coming from. In order to solve a system of three equations with three variables, we're going to use the process of elimination. In the video, I told you guys I always like to choose the first two equations for my step one. And I broke it down into 6 steps. Your book has it in 3. I like my 6 steps better because it goes through all the different pieces that you need to make sure to hit. On this example, page 25 in your book decided that it would be easiest for us to eliminate y from these first 2 equations. Why did they pick y? Yeah, there's a negative 10 here. There's just a 1 right here, 1y, but what could I multiply by so that they will cancel? We can multiply that entire equation by 10. So I'm going to multiply each piece by 10. What's 10 times 4x? 40. So I have 40x. What is 10 times y? 10y. What is 10 times 6z? 60z. What is 10 times 12? 120. We're going to take that equation, now that we've multiplied everybody by 10, and we're going to add it to equation 2 right here. So we're adding those two together. What happens when I add 40x and 2x? 42x. 10y and negative 10y? Cancels out. 60z and negative 2z? 58z. And 120 and 12? 132. 120 and 12.
Oh, I thought it was a negative 12.
Nope, we're adding. Adding those two together. All right, so we're going to take this equation, but then we're going to hang on to it, not doing anything with it yet. We have to go back to our original equations. We have to grab the one that we didn't use the first time. When I did this in the video, and what I always like to do, I like to just use the bottom 2 here. Your book decided that we would use the top one and the bottom one. And that's okay. So they're using equation 1 again and equation 3. What did we get rid of the first time? Which variable did we make cancel? Y. You have to make the same thing cancel out the second time. You don't get to pick a new letter for this part. Whatever you got rid of the first time, you've got to get rid of the same thing again. If I add those y's together right now, will they cancel? No. What do I need to do to them so that when I add them, I cancel? Multiply everybody by negative 8. Negative 8 times 4x is what? Negative 32x. Negative 8 times y? Negative 8y, so minus 8y. Negative 8 times 6z? negative 48z, negative 8 times 12, negative 96. So we're going to take this equation, and we're going to take equation number 3, and we're going to add them together. Negative 32x plus 3x, negative 29x, negative 8y and positive 8y. Cancels out. Negative 48z and a positive 19z. Negative how much? Because I have negative 48 and a positive 19. I just can't hear the number that's being said. Close. Very, very close. It's negative 29. What about negative 96 and a positive 38? Negative 58. So I've got this equation here, and we've got the equation from the previous page. Which variables does this equation have? X and Z. Look at the one that we have from the previous page, down at the bottom. Which variables did that one have? X and Z. Absolutely important that you check that before you move on. You make one variable cancel out, you have to cancel out the same variable again. So now I have two equations that have just X and Z in them. All right, so I've got those two equations right here. We got this one from bottom of page 125. We got this one from the step above. And we're going to add these two together. If I add these two together right now, 42x and negative 29x, will they cancel? Will my x's cancel out right now? Nope. What about my z's? Will those cancel? No. The directions here say to multiply by 2. Why do you think they're telling us to multiply by 2? What happens if I multiply this equation by 2? What is negative 29 times 2? Negative 58. Why is that helpful? What happens? Cancels out with my z now. If I multiply everybody by 2, my z's will cancel. 42x minus 58x gives me negative 16x. 132 minus 116 gives me 16. What do I still need to do to get x all by itself now? How do we get x alone? Divide both sides by negative 16. And that's how we get that x is negative 1. Once I know that x is negative 1, I want to stick with just these two equations that are here that have x and z in them. I'm going to pick one of those two equations, and I'm going to sub x back into it. Your book chose the top equation. Would we get a different answer if we went with the bottom one? Would we get a different answer if we went with this one instead of this one? No. Why do you think the book picked the top one? They're big numbers regardless, right? What is slightly better about this equation? It's positive numbers. You're going to get the same answer either way, but I tend to prefer working with positive numbers rather than negatives if I can help it. We're going to take our answer for x. We're going to substitute it into that equation in the place of x. So I have negative 42 plus 58z equals 132. What do I need to do to both sides here? I want to get z all alone. What do I do to both sides? I'm going to add what? Add 42 to both sides. Head up for me, sir. So I have 58z equals what? What's 132 plus 42?
74.
174. How do we get z all by itself now? Divide by 58. Grab your calculators and help me out with that real quick. Z is how much? 3, yes. So what have we found so far? We found x and z. What was x? -1. What was z? Z was 3. Are we done? We have to find y yet. I need to go back to an equation that has a y in it. Where do we have equations that have y? The original equations all the way back at the beginning. If you need to stand up and walk around so you can stay awake, that's okay. We're going to take our answers for x and for z. We're going to substitute it into any of those original equations we want to. Why do you think they picked this one? It's positive and it's easy numbers, right? What are we putting in the place of the x? -1. What are we putting in the place of the z? 3. What's 4 times -1?
Negative
-4.
4.
So I have -4 plus y plus, what's 6 times 3? 18. What do I get if I add -4 and 18 together? 14. So this is 14 plus y equals 12. What do I need to do yet to get the y all alone? Add 14? If I add 14 to 14, I'll get 28. So let's subtract it. -14 from both sides. What is -12 minus 14? -2. My ordered triple, I need it in alphabetical order, X, Y, Z order. -1, -2, +3. There's my solution. I want to go look at example number 2 with you, which is on the next page, page 127. We're going to eliminate one variable. If I'm looking at these top 2 equations, which one looks like it would be the easiest to get rid of? Which variable do you guys want to get rid of? X. So what do I do to get rid of x here? What would I need to multiply by? 4. Let's multiply everybody in this equation by 4. What's 4 times -x?
Negative 4.
-4x. What's 4 times 5y? 20y. What's 4 times -4z? -16z. And what is 4 times -2? -8. So far, so good? All right. So we're going to take this equation right here and we're going to add it to equation 2. What happens when I add my x's together? They cancel out. What happens when we add the y's together? They cancel out. What happens when I add the z's together? What number am I getting when I say they cancel out? 0. So 0, 0, 0. This entire side is 0. What happens over here after the equal sign? Still get a 0. 0 equals 0. Is that true or not?
Yes.
That is always true. This indicates that the first 2 equations represent the same plane. These first 2 equations are describing the same flat plane. So now I have to check the third plane. We're going to take this equation right here. We are going to combine it with this equation right here. This is equation 3. If I add these two together as they are right now, will anything cancel? I have a negative x and a negative x. That would give me a negative 2x. I'm talking about just the ones that I have circled in red. No. What do I need to do to this equation right here if I want to make it cancel with this equation? Multiply everybody by negative 1. What's negative 1 times negative x? X. What is negative 1 times 5y? Negative 5y. What's negative 1 times negative 4z? Positive 4z. And negative 1 times negative 2? 2. We're going to add those two together. What happens to the x's? They cancel. What happens to the y's? Do these cancel? What do we get? Remember, when I'm subtracting, I'm moving left on the number line, negative 6y. What about with the z's? What do I get when I combine my z's together? Plus 3z equals 1 when I add 2 and negative 1 together. The planes intersect in a line. This equation right here has two variables. And so that means it is a line. When do lines stop? They never stop, right? Lines never stop. Planes never stop and lines never stop. So if I want to know where these three planes are intersecting each other and we say they're intersecting in a line, how many points would satisfy? An infinite number. There's an infinite number of solutions, so we would say infinitely many. Right. I want to look at one more with you guys real quick. It's one of the check problems down at the bottom. This one won't take us very long at all. If I'm looking at these top two equations, which variable do you guys want to cancel? X, Y, or Z? We get to decide. Z sounds good. Let's cancel Z. Do I need to multiply both equations by something to get Z to cancel? What do I need to multiply by? 6, positive 6, negative 6. So I'm going to recopy that top equation, 3x minus 18y plus 6z equals 7. What do I get if I multiply the bottom equation by negative 6? See, negative, we're multiplying by 6. Negative 42x plus 12y minus 6z equals negative 6. Let's add those together now. My z's cancel. How many x's do we have? What do I get when I combine my x's? Negative, was that negative 39x? What about when I combine my y's? Negative 6y equals what? Equals 1. All right. Since we canceled the z's out when I use these other two equations, we have to cancel z again. So what do I want to multiply by this time to make z cancel? What are we going to multiply by with these bottom two equations if I want to make z cancel? Multiply everybody by positive 2. So 14x minus 4y plus 2z equals 2. I'm going to add that to negative x plus 6y minus 2z equals negative 2. We multiplied by 2. We multiplied this top equation by 2. So far, so good? So that's how I got 14x, negative 4y, 2z, and 2. What happens when I add these two together? I get 13x plus 2y. Z's cancel, and it equals 0, right? All right, so now I'm going to use this equation and this equation. Which one looks like it'd be the easiest to cancel, the x's or the y's? The y's. What do I multiply by to get the y to cancel? 3. If I multiply everybody here by 3, what's 13 times 3? 39. What's 2 times 3? 6. What's 0 times 3? 0. Here I had negative 39x, I had a negative 6y, and I had a 1. What happens when I add these two together? This one cancels, this one cancels. Does the other side cancel? Is 0 equal to 1?
No.
So what does that mean?
No.
No solutions. All right. Nice work, guys. You guys do have homework that is due tomorrow. You have 5 problems like this to do. They are on our McGraw-Hill site. Those are the numbers if you want to work them out in your book. If you would like some paper so that you can do them out on paper by hand, just let me know. Tomorrow I'm going to pass out the review for the test. Your test is next Tuesday. So I'll pass the review out tomorrow. You guys will have class time to work on the review. On Monday, I'll take any questions that you guys have from the review. And then test is Tuesday. Yes, ma'am. Can you use what? Yes, absolutely.
Can I use the bathroom?